Practice set 9, problem number 3. Given a process with a mean x bar of 12.75 centimeters and a standard deviation sigma of 1/10 centimeter, label the mean, the upper control limit, and lower control limit values on the line below. The mean has been done for you. So the mean is given. To find the upper control limit, which we will abbreviate UCL, we will take the mean plus 3 times the standard deviation. So for this problem, we have 12.75, the given mean, plus 3 times the standard deviation, which was given as 1/10. Order of operations will multiply first, giving us 3/10, and then do the indicated addition, giving us 13.05, the value of our upper control limit. The lower control limit, or LCL, is found by taking the mean minus 3 times the standard deviation. For this problem, we'll start with the given mean and subtract 3 times the standard deviation. Again, multiplication first. We have 3/10 after multiplying. Subtracting it from 12.75 gives us a value of 12.45. Going 3 standard deviations above and below the mean, these values, in other words, our upper and lower control limits, is representing 99.7% of the process output. In B, given product specifications of 12.7 centimeters plus or minus 15 hundredths of a centimeter, mark the location of the ideal measurement, the maximum allowable size, and the minimum allowable size. Well, the ideal measurement is the first number in this tolerance, and it would be to the left of the mean if we're looking at this as a number line. So here's our ideal measurement. Next, they're asking us for a maximum. And given this tolerance has the plus or minus, the maximum value will be found by adding that tolerance given, which when we add those together, we get a 12.85. That's more than 12.75, but less than 13.05. So somewhere along this number line, we would put the value of 12.85 is the maximum. The minimum then is found by taking the ideal measurement, 12.7, and subtracting that tolerance of 15 hundredths of an inch. When you subtract that, we end up with a 12.55. 12.55 is larger than our lower control limit, so our minimum is going to fall between the lower control limit and the ideal and has a value of 12.55. In C, it says, based on parts A and B, it is likely or not very likely that parts produced by this process will be out of specifications. Well, the process is represented here by the lower and the upper control limits, which is, as I said before, 99.7% of the products being produced. Since those values lie outside of the minimum and the maximum, it's likely that this process will produce items that are out of specifications because they're making products that are smaller than the minimum, and because of this being our upper control limit, they're making products larger than the maximum. So likely would be our answer.